Hello, everyone, and welcome back to the Greenstat Asia webinar series. I am Pritika Murugeshan and engineer project and proposals at Greenstat Asia. I work on techno-economic feasibility and stakeholder engagement across green hydrogen and its derivatives. It is truly wonderful to see you all join us today from across the region and around the world. Thank you for taking your time to be here. It means a lot to us. So today's session is titled Decarbonization in the Shipping Sector. This is especially important and a timely discussion as the global maritime industry moves toward cleaner operations, new fuel pathways, and ambitious net zero targets. Over the next hour, we will explore the revolving and evolving regulatory landscape, the rise of alternative marine fuels, and the cross sector collaboration required to build a sustainable maritime future. Before we begin, let me take a moment to introduce who we are. Greenstat Asia is a clean energy consulting company dedicated to accelerating the transition towards renewable energy, particularly green hydrogen, through the Greenstat Center of Excellence for Hydrogen. Based in Sri Lanka, we focus on knowledge sharing, capacity building, and global collaboration. We work closely with universities, government bodies, and international experts to advance hydrogen technology, safety, policy, and the entire value chain. Our goal is to support emerging markets in building strong, future ready hydrogen ecosystems. It is now my pleasure to welcome today's distinguished guest speaker, Mr. Manish Saxena, CEO at Xtrac Tech, who brings over 36 years of experience in the maritime industry. His career spans senior leadership roles in fleet management, environmental compliance, and global operations. Before joining Xtrac Tech, he spent more than 20 years with Anglo Eastern Ship Management, where he served as managing director and led major operational and organizational transformations. At Xtrac Tech, Mr. Saxena focuses on innovative environmental solutions, alternative fuels, carbon capture, and strategies aimed at achieving net zero carbon emissions in India's industrial and shipping sectors. His practical insights and leadership across India and Australia make him the perfect expert to guide today's conversations. Before I hand over the session, just a few quick housekeeping reminders. Please type your questions into the Q&A box at any time during the presentation. We will take all questions during the Q&A segment toward the end of the session. A recording of the webinar will be shared with all registered participants in the coming week. With that, let's dive into today's session. Mr. Saxena, the floor is yours.
Thank you, Pritika, for the wonderful and the kind introduction to me. Today, we are here to discuss the decarbonization in the shipping sector. And within the agenda, next slide, if you can. We have the key topics that we will cover would be low carbon footprint in shipping. And we will review the International Maritime Organization rules and regulations, current EU regulations, and alternative fuels and how they would fit specific maritime use cases. Finally, we'll look at strategies for fleet renewal or retrofitting and emphasize the importance of cross-sector collaboration to achieve these goals. So next slide, please. So if you can see this graph, this is the world emissions as we stand today. In 2025, we were supposed to level off with our anthropogenic CO2 emissions. We seem to be running behind time. So as we forecast, by 2029, we would already have reached the 1.5 degrees centigrade increase of world global temperature as compared to the pre-industrial age. And that was what was set by the Paris Climate Agreement way back in 2015. Somehow the stakeholders in this have been rather slow because of various reasons. And even if we achieve and at this present rate, and considering that by 2060 we level off with any emissions, we still will likely end up close to 2.2 degrees centigrade by the end of the century, 2100. So that is the scenario which we are looking at. And unfortunately, 1.5 degrees centigrade benchmark has been given by after a lot of scientific thought and due processes, and 2 degrees was the last limit that we could have gone to. The emissions currently we have, if we have to reach 1.5 degrees centigrade, we have close to 155 gigaton as what they call the carbon budget, if you can see it on the screen. So we have various sectors which contribute to emissions, as you can see: power, transport, manufacturing, and others. So next slide. Where does shipping stand in this? Shipping contributes to 3% of the global CO2 emissions and carries 80% of transportation by any means. So, but within the 3%, there is a huge drive from the IMO, the shipping, various collaborators to further reduce the emission. And considering that we will not, if we don't do anything about it, then we look at increasing it by 130% emissions. And shipping, as you know, is central to global trade. And so what are the factors which are incentivizing the owners and the various stakeholders to achieve this goal? Next slide, please. So these are the IMO targets which have been set by IMO. If you can see this graph. So we were supposed to be close to 2000. By 2030, we are supposed to reduce the emissions by 20%, 2040 by 70%, and 2050 by net zero. And these are the very aggressive targets which have been set off by the IMO. And shipping industry, for various reasons, is also grappling to reach this. So way back in April 2025, there was a mechanism which was jointly agreed by most of the IMO member states of a two-stage. If you can get to the next slide, please. Yeah, so this is the IMO's net zero framework, which provides a structured approach to the maritime sector to achieve net zero emissions. And if you can see, this is a tier 1 and a tier 2 compliance strata, and how there are levies being applied onto the operators and owners who run only on conventional fuels and are not keen to switch on conventional fuels. So now, of course, so in October 2025, there was not enough consensus for this rule or regulation to be finally adopted. And it has, because of pressure from some countries, and now we are in a state where this has been temporarily shelved, and we are going to look at it after a year's time. So, and there will be some sort of negotiation. This graph is only just for reference purposes, because this is not being followed for the time being. What other rules and regulations do we have? Ritika, if you can come to the next slide, please. So the maritime industry is at the cusp of a major transformation. But the very fact that we need to do something transformational, and which is something akin to graduating from steam engines to, or rather sailboats to steam engines, and steam engines to internal combustion engines. This is going to be a tectonic shift if we have to reduce the greenhouse gas emissions. Next slide, please. So these are EU regulations which have been in force since 2024. So they are also, EU has made its own set of rules, and it covers all emissions between EU ports and half of emissions for voyages starting or ending in the EU. And so this is to reduce fuel consumption and reduce the carbon factor. Now, how this cap and trade emission system works is that one EUA or one EU allowance allows you to emit 1 ton of CO2 equivalent. So every ton of fuel oil burnt emits 3.2 kg tons of CO2. And every ton of CO2 is charged, and within the cap and trade system, you may have investor sentiments going up and down, and sometimes now the current rate going is around 90 euros to a ton of CO2 which has been emitted. So that is one regulatory way, and now 2025 onwards, there is another thing which is called FuelEU Maritime, and which sets mandatory limits on GHG intensity of fuels. This is something which has been brought forward from the original EU Fit for 55 regulation, which was brought out in 1990, and it had a target of reducing the emissions by 55% by 2030 as compared to 1990 levels. And the thrust of it is to use alternate fuels. Also, ports, if they could provide coal lining, which is sort of plugging in with the electricity charger instead of running the diesel generators at port. So these also cover, or these both of these incentivize the ship owner and the charterer to go for alternate fuels. Now for EU ETS, the simplest way is to go for biofuels, which is a drop-in fuel, and it is easy to substitute, at least for the operational side. So next slide, please. Now, what we are also looking at is the beyond the governmental institutions. We have the non-governmental institutions also, which are driving or propelling the shipping fraternity to go for low carbon footprint fuels and trying to accelerate maritime decarbonization. Now, these are the financial institutions which are green financing the ship. As you may know, it's a highly capital intensive industry, and they have their own sustainability targets, and green financing is part of that. There is something called Poseidon principles, which are which allow the banks and financial institutions to extend credit to the ship owners for building new ships, basis their following or their coming into the ambit of rules and regulations for decarbonization. So otherwise, their finances are hindered. Then we have the cargo owners, a thing called ZEMBA, which is the Zero Emission Maritime Buyers Alliance. These guys, this is a set of people who only try to buy alternate fuels for ships. If they have to, they will have cargo on the ships only if the ship is using alternate fuels. So that's a very aggressive approach. And similarly, there is something called a sea charter. Now, the sea charter is a set of charterers who take cargoes and who charter vessels only if there is if the ship complies with a certain standard parameter of decarbonization efforts that it is being. So both these from the owners, from the charter side, this is a huge pressure onto the ship owners to sort of convert into alternate fuels. And then every corporate entity, whether it's a ship owner, whether it is a charterer, they have their own ESG commitments that they have to report to the board, and thereby they have their own internal pressures of taking the right steps towards the decarbonization. Next slide.
Sir, can you hear us?
Uh, Yeah, so these are the decarbonization solutions which are available to the ship owners. And you can see these are broadly into 5 categories. So one is logistics and digitalization, by which is those the subheadings are under the speed reduction, where the ship can reduce its speed to reduce the fuel consumption if it is not required to reach urgently, and thereby reduce emissions. Then there could be a vessel utilization whereby you can have, instead of ships carrying part cargo, one ship can take the full load of cargo. Then you can have, a vessel size suiting the cargo to be picked up. You can't have big ships if there are very less cargo, amount of cargo there. And then alternate routes. Now, alternate routes, there is a lot of improvement in the satellite technology, and there are many softwares which uh, provide proper routing to the ships if they have to go from port A to port B, which essentially it means that the shortest distance between port A to port B may not be the one which has the least amount of fuel consumption or thereby the lowest emissions. Because of the wind and the waves and the currents or the tides, there could be slightly alternate routes which lead to faster commute as well as lower fuel consumption, and thereby so there, with the various combinations, with the correct data in hand, with AI tools, you can have a fuel emission reduction for 20%. You can also have now there are others which are hull coating. Now, hull coating is very critical to providing the resistance to a vessel when it sails. So if it is, there are various paints which are there in the market, the high quality paints which are, which are very expensive, of course. They provide least resistance and thereby reduce the fuel consumptions. Then hull form optimization is something which has been increasingly used, whereby they, using proper modeling, they make the hull form in such a way that the resistance of the ship is decreased. Then you can have the propeller, which is now being retrofitted with the increased efficiency. Then you can have the rudder, which has a better wake and a flow property around it. Air lubrication has been in use for quite some time, but there are mixed reactions to it. But now what I'm given to understand that air lubrication is coming back into fore to reduce the resistance around this air lubrication is basically with they have bubbles coming out of the of the ship and reduce the friction between the water and the hull. So that is air lubrication. And cleaning is, of course, as you may know, most of the ships go for dry docks, which is cleaning of the hull every 3 or 5 years, or 5 years they have to do twice. And if you have underwater cameras or such devices, you can know the condition of the hull beforehand and get it cleaned underwater. So that once a clean hull will obviously form a lesser resistance to the movement of the ship while the ship moves. Machinery, coming to that, is machinery efficiency improvements. It can be with the tuning of the engine. You can renew worn out parts of the piston liner, piston rings, etc., and thereby increase the fuel efficiency. Waste heat recovery are broadly into two categories. One is from the jacket water, where you can generate fresh water from it, and from the exhaust gases. From in some trials, there are now turbines which are being driven from the exhaust gases. Engine derating is also being used by some of the fast-moving ships of containers and cruise, mostly containers, where they feel that derating the engine can reduce the fuel consumption. And battery hybridization and fuel cells are more into the coastal area, and it's for smaller vessels, not for big ocean-going vessels. Now, the next part is the net zero framework, which is what is now being focused at, and that is the leap forward that we all have to take in case there has to be a drastic reduction in the carbon emissions, which could now be between close to 0 to 100%. So in this sequence, biofuels are the natural successors to fuel because they are normal drop-in fuels. Not much is required, and the blends have been effectively used to a 30-70 or 20-80 ratio with the conventional fuels. However, biofuels are have to compete with the agricultural or farm products. So there could be supply issues at times because obviously food is something which takes precedence over fuels. I will go through it a little bit in the later slides. Electrification, a lot of equipment on board are using more of electrification is there. Methanol, ammonia, we'll just cover in the slides a little later on. Hydrogen as a has two ways it can be used in cell form or in direct combustion. But for big ocean going ships, again, it remains a huge challenge because the hydrogen cells, the hydrogen as an internal combustion is difficult. Not many engines have it, and only trials have been made on the smaller ones. Hydrogen fuel cells have been used in ferries, and now they are into increased usage. Wind power, we have those. There are 3 or 4 different designs of wind turbines now, which have been installed on a trial basis, and they have been able to save fuel to up to 20-25%. Of course, these are expensive and they have a lot of big footprint on the deck. And importantly, they don't function on a continuous basis. It all depends on when the wind comes in. Nuclear is the next one. Of course, it has got a lot of negative general perception of having it. Nuclear has, as you may know, that it has been used on the naval ships for decades, but it is an extremely costly affair to have a nuclear ship as a commercial entity. Of course, it has zero carbon footprint and minimal radioactivity in the type of SMR, which is the small and medium reactors. So the waste is not as much, and it can easily be done. But the cost is a huge factor, and the regulatory part is something which has not even started. Just on the very starting point is where we are at nuclear energy on board commercial vessels. Last but not the least is the after treatment, carbon capture from the exhaust gases. Again, there are huge logistical challenges, not only because carbon dioxide is a very difficult gas to store in a liquefied form, and you will expend a lot of energy trying to keep it in liquefied form, especially if you have a long voyage ahead of you. And eventually, there have been the liquid carbon dioxide in experiments and in trials they have in Norway, in China, and others. They have been able to pump this liquid carbon dioxide into old oil wells or some sort of sedimentary rocks where this is sort of stored on a permanent basis. So, but the logistical challenge and the energy required to keep it cooled under those conditions is huge. And shipping industry as of now has not really gone deeply into it. It's just a lot of trials are going on in this carbon capture segment. So yeah, next. Yeah. So let us see the forecast of alternative fuels. So you can see the rapid growth in non-fossil fuels within the maritime fuel mix, and these alternate fuels overtaking fossil fuels by the 2050s. This will reflect increased availability, technological advancements, and regulatory support for cleaner fuels. And you have a major transformation in how ships are powered in the coming decades. And you can see that in the green line, the non-fossil fuel increases up, and the fossil fuels show a downward decline. Actually, 2025 should be the year where the emissions have to be stagnant, and they show thereby from 2030 it should have a downward trend of fossil fuel consumption and the increase in the non-fossil fuels. So this is the scenario of how the ships on are as of now on alternate fuels. We have only 9% of ships which are on alternate fuels. The remaining 92 or 91% of the fuels of the ships are still under conventional fuels. And of the 9%, we have a high rate of close to 7.9 LNG and the others. And what we have for the gross tonnage on order, you can see 51% are still 51% are on alternate fuels. The remaining 49% are still on conventional fuels. That is the vessels on order, and of which you can see that 37% are on LNG. Now LNG has its own plus and minus. Mostly the LNG ships which are being ordered already have cargo as LNG. So when you have cargo as LNG, it's easier to burn them. There is a lot of debate because I'll come back to something called a GFI, which is a GHG fuel index of LNG is even higher than the conventional fuel oil if you use it using the gray LNG. But if it is green LNG or blue LNG, then it is much lesser. So here we are talking about greener LNG. Methanol again is you need to have green methanol and they are looking at 11%. Importantly, now vessels are being made with a dual fuel option that they are made for conventional fuels and they leave aside equipment and structure for the later fuel, alternate fuel when it comes to in the market. Now you can have a look at the next slide, the forecast of alternate fuels. So if you come to the section of energy density, you can see that MGO or gas oil has around 39 megajoules per liter. LSFO or low sulfur fuel oil is around 41. LNG is 21. And methanol is close to half or even less, and same goes for ammonia. So which essentially means that you will have to have almost twice or more than twice the volumetric consumption of methanol and ammonia to reach the equivalent of MGO or VLSFO. In other words, this means that you need to have a larger carrying capacity and more of fuel consumption. Next slide, please. So this is a fleet a comparison of marine fuel options. cost, energy, density, and you can see this is the GFI of the heavy fuel oil. If you see, it is 91. Now, GFI is the GHG fuel index, and it is the weighted average of all, and it counts the energy consumed from well to wake. Well is from the time when it is being taken from its source, and wake is the time when it is actually consumed in the engine. So if you can see here, methanol fossil is close to 100, and the higher the GHG, the poor is the emission, and the more is the emission, and the poor is the poor quality of fuel it is in terms of carbon emission. And and the methanol bio is almost at a 30, which is less than 1/3. So all depends on where even though the methanol at the end product behaves exactly the same, source is where the difference comes. And if the ship owner is using a fossil methanol, he is burning much higher fuel with a much higher carbon content. On the left-hand side, also you can see the energy density is in the middle, and on the left-hand side, you can see the prices, which are a huge factor in deciding as to which fuel you have to choose. If a normal heavy oil comes at 500, you can see the methanol bio comes at 1100. And we are in, and if we have to burn an equivalent heavy oil, we are actually have to double the methanol bio. So you have a $2,200 as against $500 of HFO, which are equivalent. Or if you can see, this is 20 as the energy density, and this is 40. You need to have twice, and same goes for ammonia. Now, they have in these are more for European prices, and as what we hear latest, India, China, and Asia, they have been able to get methanol bio at less than 600. So that's a huge achievement, and others are also going for it. And this is a prime driver, because if you are using a very high one, you have already spent a lot of money in converting your ship to an alternate fuel, and second, if you have a high cost of fuel, then you run out of the market. You are pushed out of the market in terms of cargo. So because it's a huge impact on the running cost of the ship. Next. So this is the multi-criteria evaluation of alternate marine fuels, and where we have listed out the favorable and less favorable. If you can look at heavy oil, everything is good with it. There is no engine modification, but it has a very high GFI. And methanol fossil also has a high GFI. Ammonia has a high GFI. They are the conventional fossil fuels. And green is, of course, we have tending towards more favorable. Engine modification is a major challenge, because you have only two big engine makers, BMW and Wärtsilä, and they have a huge long list of order piles for conversion. So there again, we have a scalability, calorific value, a price per ton, and infrastructure readiness. Next. So just to give you a rough idea, if I have to store methanol on board ships, then methanol has got a low flash point, and it is colorless liquid. So the idea is always to keep the fuel underwater level, and you can see that there is a cofferdam, which is a space between the fuel tank boundary, and there is another artificial boundary created between the other machinery space, where you pump in inert gas, so that the flames, the fuel vapors do not sort of are not becoming a safety hazard, and these sort of they act as a barrier between the cargo or the machinery space and the fuel tanks. And you need to have proper venting, and there is an increased factor of safety, that needs to be put in place by the regulatory authorities and for the crew to be working in a safe atmosphere. The best, as I mentioned earlier, green methanol is got a property of being a drop-in fuel as opposed to all the other fuels which are cryogenic. Both LNG and ammonia and hydrogen, etc., are all cryogenic, which means that they are sub-zero in terms of storage and containment and usage. So next slide, please. So next is ammonia. Of course, we are only talking about green, and ammonia comes with its own set of challenges. Uh, of course, it has no carbon molecule to it, so it doesn't have any carbon footprint, but it does have the other GHG gas, which is N2O, nitrous oxide. It is very toxic, pungent, and difficult to handle. Again, the crew has to be suitably trained. And on the right-hand side, you can see that this is how ammonia storage is required. You need proper venting, you need proper safety, and that's a typical layout, a schematic layout of how an ammonia engine or a vessel has to be designed. Ammonia also has a huge auto ignition lag, which means that there has to be a fuel injection via the MGO or gas oil, and then after the pilot fuel has been ignited, only then can ammonia come into play because of its low auto ignition properties. It fires late. So next are biofuels. Some of it I have already touched part of it. These are primarily from two different. I mean their production is two FAME and HVO. FAME is more commonly used, which is the fatty acids methyl esters, and you use transesterification to make FAME. For HVO, you use hydrogen to get to the hydrogenated vegetable oils, and they have the paraffinic hydrocarbons are more compatible with the existing fuel systems. Biofuel again is the easiest to use the alternate fuels, but again the supply is still remains a question mark in many parts of the world. So next, this biofuel production by feedstock. If you see the first column, ethanol. Ethanol comes from sugar cane and starches, but it has not been adopted into the maritime field for reasons that they are purely, from feedstocks and of sugars and starches, and most of the ethanol is being used by the road industry. I mean the trucks and the vehicular industry. For the maritime, you have the FAME and HVO, and you can see that almost 70% comes from vegetable oils, and the remaining ones comes from residual oils, which could be used cooking oil, it could be other oil residues. And biogases have still not found a place in the maritime field. So for an organization, what is the best way forward for a short term? So they have to strategize, and for short term, as we saw earlier, they have to look at digitalization and all the other means of reducing their carbon footprint, as well as trying to get biofuel into their scheme of things as an alternate fuel. Medium term, they can look at changing their. They have to align with flexible fuel pathways, which means that they have to go for either ammonia or methanol, which are the two fuels now being prepared for the maritime future. And they have to see the cost of retrofits is quite large. For a 10-year-old vessel, changing to a methanol engine would be setting the owner back by 30 to 40% of the current cost of the vessel. Same thing for ammonia, it can go to 40 to 50, and for LNG, it can still be higher. So a pragmatic choice has to be made between a vessel continuing to run the ship or to scrap it and look for a new one. So just to give you an idea, the shipyards in China, Japan, and Korea, which are the ones where we normally the whole world comes in for, and which we have 95% of the shipbuilding activity going on, they are chock-a-block full till 2028 for vessels being built on alternate fuels and otherwise. Long-term solutions are carbon capture and nuclear technologies. The regulations and their technologies are still in the nascent stage as far as the commercial part goes, commercial ships goes, and they have still a lot of challenges to be overcome. So again, if a owner has a fleet of vessels, then, sorry, this is the second last slide. A fleet of vessels, then he has to look at the status is the age and type of the vessel, whether it is even worth running that, or whether it is worth to continue running, or whether it is better to scrap the vessel in case there are heavy penalties which are being levied. Market dynamics is where they have the see how much charter hire is, whether it is worth running the ship in that high fuel segment, or whether it is better to take the ship off. Technical feasibility, whether the ship is as big to arrange for the conversion, or because every conversion will put the owner back by a couple of million, $10 to $15 million and more, plus 3 to 4 months of downtime. So they have to look at the technical feasibility. Economic planning is something similar to this. Fuel and energy efficiency is something that has to be put into the planning, and each owner has to look at the pathway that he intends to have. It is not only about the fuel itself, it is the infrastructure as to where he is going to get the fuel from. That is also important. Fleet construction, there are various sections where they have to look at for the fleet construction operation, shipyard selection and construction oversight. Next one. So cross-sector collaboration. Now, this has to be a multi-sector collaboration when you are looking at alternate fuels, because the very fact that you need to have, even if my ship has an ammonia or a methanol run engine, I still need the fuel. I need to have the green infrastructure for green fuel bunkering. They have to have the safety regulations. They have the safety systems in place. Fuel suppliers are, of course, a critical part where they have to give uninterrupted supply to the ship, and she doesn't stand at port just because they are waiting for a particular green ammonia or a green methanol or a green fuel of that kind. Technology providers are as I said, mentioned earlier, they are the MAN and the Wärtsilä, two major engine makers, and they are already into dual fuel engines. Dual fuel is running on conventional fuel as well as running either on ammonia, methanol, or LNG. That is a dual fuel. And they should have the proper monitoring tools in place. International partners are important. Even IMO doesn't set the rules for, they have a broad guideline of fuel, but there is another subsector of fuel suppliers which frame the rules for proper fuels that can be used on board ships. So what do we have here is something being talked about are the green corridors. And to give you an example, one green corridor is from Europe to Asia, from Rotterdam to Singapore. Other is from Australia to Japan. Now, what are green corridors? Green corridors are have ports where the alternate fuel supply is ensured. The safety part, the regulatory part is all taken care of, and the supply of For example, Singapore, a port like Singapore already has alternate fuel facilities, or Rotterdam, they have a steady supply of ammonia, they have a steady supply of green methanol, and that's a green corridor, and which all the, and it's again a huge capital cost required. A lot of capital cost is required of it, and the governments have to be involved in that for that capital injection. The cargo owner also should be very much committed to using alternate fuels. Ship owner whose ship has to have that alternate fuel engine, and port and fuel supplies, as I've already mentioned, is critical to how we the ships on alternate fuels. So we come to the last slide, and conclusion is that the transition to net zero is underway, and there are different pathways. All of the stakeholders have to commit together and come to a point where we have to have, a very unified strategy to reduce our carbon footprint, to decarbonize, whether it is the ports, whether it is the ship owners, whether it is the charterers, the banks, the financial institutions, and so on. And we have to go to the 2050 with net zero shipping. Of course, as how we are going, it's unlikely that we might reach this point, and people are talking, even whether shipping or otherwise, it looks difficult that this target can be realized. But nevertheless, if you don't have the goal and the target in sight, we won't ever reach even close to it. So that's my take on it. And thank you very much. I'm open to questions if there are any.
Thank you very much, Mr. Saxena, for a very scintillating and insightful presentation. Your extensive knowledge of the decarbonization and maritime industry is truly admirable, especially the solution, fuels, retrofit options, fleet renewal, green corridors was extremely good. They were laid out extremely systematically. Thank you so much. So I would now like to ask the participants to post any questions that you may have in the Q&A box. Or if you directly want to interact with our speaker, you may please raise your hand. I would unmute you to speak with our the speaker. Yes, I think we have a question from Mr. Rahul Sharma. How serious are shipping companies towards decarbonization goals? Do you think the recent change of direction by IMO has pushed the target further?
Very good question. And it's very much a chicken and egg syndrome. Ship owners are waiting for regulatory guidelines to go about. Many of them are still not clear as to which way the world is going to go in terms of regulatory framework. Yes, they are committed, because of the very fact that most of the ship owners might not get the capital to run their ships or build their ships if they don't comply with green regulation. Shipping has always been a very, very conservative entity, and they have been less of voluntary work on decarbonization than more of regulatory work, regulatory stuff thrown at them, and that is how they react. So the MEPC 83 was a very good tool to begin with, but unfortunately it was not adopted in the final resolution in October this year. And there were some vested interest, or, if it had gone through, we would have seen a drastic change from 2028 with alternative fuels coming into force much quicker. Now, having said that, there is also has to be a very, very focused approach from the governments and the other stakeholders, as I mentioned earlier. They have to have buy-ins from the governments in terms of getting the infrastructure on ports for supplying the fuel suppliers of alternate fuels, manufacturers, they have all they have to come on board together and form a unified front to fight this, this menace of decarbonization, the carbonization, and reach the decarbonization goals of 2050. So yes, there are, especially from European sector, there is a huge interest and you can see the European regulations also being made towards decarbonization, very clear, as I just mentioned, EU ETS, FuelEU, Maritime. They are there to incentivize and leverage the vessel owners into and pushing them into using alternate fuels. So if we have to pay those, and the penalties have already started to come. FuelEU Maritime will start to, EU ETS has already started from 2024 onwards if you have to trade your vessels in Europe. If you have to, and FuelEU Maritime comes in force from 1st January 2025. So both of them are going to be, these levies are going to be taxing on the ship owners, and they should, if many of them are smart, they would sort of change. Thank you.
Thank you, sir. Thank you for the question. We have another question. Is the carbon dioxide released from an ocean-bound vessel absorbed by the seawater to form algae and plankton? How much percentage is generally released into air? Is it true that seawater absorbs nearly 30% of all the CO2 that humans generate?
So most of the, as I mentioned, most of the emissions are into the air of a vessel which is out at sea. So there is CO2 which is already trapped in the oceans, and when there is a global warming or when the seawater temperature rise up, that trapped CO2 is released. So whatever is trapped earlier it feeds the algae and the planktons. But emissions made from ships they continue to be in the atmosphere for thousands of years together and lead to global warming. I may also add that methane is a much more potent gas than even CO2 or LNG, which is methane. So methane would probably stay in the air for 10 years and then degrade into carbon dioxide and into water. But for a short answer, no, the CO2 from ships are not readily absorbed by the planktons so much. Very minuscule part of it goes into it. Most of it is released into the air.
Thank you, sir. Hope it has answered you, Mr. Pidatala. We have one more question, sir. Which emerging technologies will have the largest impact in the next decade? What milestones should we watch for in the next 5 years to gauge whether the industry is on track?
Well, milestones is more of data that is of importance. And nowadays, with the EU and the IMO insisting on a set pattern of data, like IMO DCS or even ETS and FuelEU Maritime, they insist on very clear-cut data on how much fuel has been burnt. So once and this is basis the current the conventional fuels of heavy fuel oils. Now, for the next 5 years, it is not easy for any ship owner to transform his ship into a ammonia or a methanol burning ship, because as I said, the shipyards are full. It is going to take a long time. So either way, within the next 2-3 years, it is hardly possible that you may get a order today and you get your ship in the next 2-3 years. The short-term solution would still be biofuels, and there has to be, because it's a drop-in fuel. The medium term, as I said, is between 2030 to 35 or 38. Is you're looking at alternate fuels of ammonia and methanol. So then you have more time to sort of get your fleet ready in a readiness status. And some say that even now the MEPC 83, which has been pushed back by a year, has sort of is trying to prime up the owners, the ship owners and cargo interests to move to get better readiness towards those alternate fuels, to transition towards alternate fuels. So every ship owner and cargo interest will have to have their short, medium, and long-term solutions in place so that he continues to deliver on shipping as a as a decarbonization tool
Got it.
for shipping.
Thank you, sir.
Thank you.
So one last question from Ms. Srenar Jayasundara. Considering the push for ports to provide shore power, what needs to happen on the shipping side to make this a viable solution? Are shipping lines generally ready with compatible vessels and procedures, or is significant fleet retrofitting and crew training still a major hurdle?
Yeah, good question. In fact, one of our subsidiaries is having a cold lining option. Readily, the ships are not provided with cold lining options. The targets now are container ships and cruise vessels, which have the maximum port loads. Any ship going to US is mandatory. US East Coast mandatorily will have cold lining options because many the ports of Los Angeles and California fine you if you don't have these contraptions. So one is port, other is the ship. Most of the ships are not readily fitted with the cold lining options. The target ones are, of course, as I mentioned, cruise and container. Even within them, only the mandatory ones are the ones calling the US. So the big ones, 5,000 TU and above, have the cold lining fitted, and the remaining is up to the owners to fit. China, many of the Chinese ports have cold lining facilities, and but many of the ships have to be compatible, and they are giving discounts if the vessel calls at one of the Chinese ports, and if you are willing to have a cold lining retrofit done. It's not such a simple retrofit. You need to have the ship for some sort of a layup before all this retrofit can be done.
Thank
Thank
you
you.
so much, sir. Thank you. I think that's all the questions that we have. Uh, does anybody else have any questions? We are still open for questions. You may also raise your hand. Okay. So I think we arrive at the end of the session. Thank you everyone for your thoughtful questions. Thank you, Mr. Saxena, for patiently answering all our participants' questions. I would now like to invite my colleague Pranav Marathe to give the vote of thanks as a token of our gratitude to everybody.
Am I audible?
Yes, you are audible. Thank you.
Okay. Hello everyone. Good afternoon. Myself Pranav Marathe. I'm working as an engineer for projects and proposals at Greenstat Asia. I hold a BTech in chemical engineering and have 3+ years of experience in clean energy consulting. I specialize in green hydrogen, industrial decarbonization, and sustainability energy transitions. And my work includes feasibility studies, techno-commercial analysis, and project coordination, and other as well. And coming to vote of thanks, thank you, Mr. Saxena, for an insightful presentation. Sincere thanks to all participants for listening so attentively and for the thoughtful questions and answers. Really added depth to the today's discussion. As someone closely, we can say, involved in organizing these sessions, it's inspiring to see such genuine interest in accelerating decarbonization webinars and the overall environment. Every conversations like today's bring us one step closer to the cleaner maritime future. And for the recording, the webinar recording will be shared with all the registered attendees. Thank you once again for your time and participation. Wishing you all wonderful day ahead.